Can you solve this geometry problem asked in SAT exam? We are given a quarter circle like this. Inside this quarter circle, a full circle is placed in such a way that one of the straight edges of the quarter circle touches the full circle externally like this, and the length of this tangent at the top is 14 units. And our goal is to find the total area of this blue shaded region. You can pause the video and take a moment to think about it, and when you're ready, you can always come back to verify your answer. Alright, let us solve this together. But before we begin, let's mark the radius of this quarter circle as x unit and radius of this full circle as y unit. Now if you look at the figure, the area of the blue shaded region is simply the area of the quarter circle minus the area of the full circle inside it, right? The area of the quarter circle is calculated using the formula pi times the square of the radius divided by 4. So area of this quarter circle becomes pi times x squared divided by 4. The area of this full circle is simply pi times y squared. So the area of the blue shaded region is equal to pi times x squared divided by 4 minus pi times y squared. Now let's factor out pi from both terms, and that gives us pi times the quantity x squared divided by 4 minus y squared. Let's mark this as equation 1 and put this in the corner. Now focus on the full circle placed inside the quarter circle. Let's draw a diameter of the inner circle so that it runs vertically and touches the flat side of the quarter circle like this. Since the radius of the inner circle is y unit, that makes this diameter equal to 2y units, right? Now look at this tangent at the top and this side of the quarter circle. They are both tangent to this inner circle. That means they are parallel to each other and perpendicular at the point of contact to this diameter. So if this diameter is 2y units, then this distance from the center to this tangent is also 2y units, right? Now look, this shape formed between two tangent, diameter, and this side of quarter circle. These two angles are 90 degrees. And this third angle is also 90 degrees. That means this fourth angle is also 90 degrees. Now let's draw a radius from the center of the quarter circle like this, forming a right-angled triangle. Hypotenuse of this triangle is the radius of the quarter circle, which is x units. The base of this triangle is this horizontal line segment, which is given as 14 units. The height of this triangle is this vertical line, which is equal to 2y units. So using everyone's favorite Pythagorean theorem, we have x squared equals 2y squared plus 14 squared. That is x squared equals 4 times y squared plus 196. Now divide both sides of the equation by 4, we get x squared divided by 4 equals y squared plus 196 divided by 4, which simplifies to x squared divided by 4 equals y squared plus 49. Now subtracting y squared from both sides, we get x squared divided by 4 minus y squared equals 49. Did you notice something? This expression is exactly what we had in equation 1 for the area of the blue shaded region. So now, substituting this back into the equation, we get area of the blue shaded region equal to 49 times pi square units, and that is our final answer. Pretty amazing, isn't it? Even though we didn't know the actual radius of either circle, we were still able to figure out the exact area of the blue shaded region, just using logic and some clever geometry. But hey, before you go, I have one more bonus challenge just for you. Can you find the area of this blue shaded region in terms of the x instead of length 14? Think it through and drop your answer in the comments below. Let's see who can figure it out. If you found this explanation helpful and learned something new, don't forget to hit that like button, share it with a friend, and subscribe for more mind-bending math questions. Thanks for watching, and I'll see you in the next video.